By the way, I've heard that you had a crazy ride to be on time. That's great. Okay, perfect. I think we can start, yes?
All right. Well, thanks for joining us, everyone. My name is Ken Wong, and I'm the U.S. Regional Director of Secure. And just wanted to welcome everyone to another episode of Useful Hacking Series. Today's session is Memory Analysis Guide. It's part one. It's episode 5, and it's part 1 of the memory dump. And I want to go through a little bit of some basic housekeeping with everyone. We have a little section over there where you can ask any questions, so feel free to use the GoToWebinar icons to raise your hand if you have any questions or answer any of the questions at all. At any time, I'll be monitoring this throughout the session, and I'll definitely let Paula know if you have any things that you want her to revisit or talk about towards the end of the session. But without further ado, I'll have Paula Januszkiewicz take over. Paula, go ahead.
Yeah, absolutely. Thank you so much. So, yes, as Ken mentioned, this is the episode number 5. If you want to see the previous episode, we've got our YouTube channel as well. We also post a lot of information on our Facebook page. So, if you don't mind liking it, we'll be absolutely honored. And then you, from your side, you're gonna get an update about different types of tools that we write. And we actually finished just yesterday another new tool. Very nice to analyze a prefetch on Windows 10 because there's plenty of things that have changed. So if you want to hear about that, like us on Facebook, and we're going to post there different types of news. We're becoming a little bit more active over there. Okay, so this was me speaking at the very beginning, and my name is Paula, and as you could see on the invitation, and what I do, pretty much I'm a security expert, I think I could say that, delivering different types of penetration tests and delivering different types of security consulting and also training. Yes, so in the United States, Ken is responsible for the whole secure part, of course, including the Secure Academy, which is technically our trainings. So this is about that. Yes, and. A little bit info about myself. I was also rated #1 speaker at Microsoft Ignite, which pretty much indicates that there is a lot of people interested in security, which we are super happy to hear because we would like to share with you a bunch of news. Of course, I have to mention that in my 2nd to 6th, we are running Hacking Securing Windows Infrastructure Workshop, our bestseller. So basically, if you want to sign up, this is an offline class, so we actually see each other. Go ahead and do it. If you have a request for the different date, let us know, and then we're going to adjust the timing. Anyway, let's start. So today we will talk about the memory analysis. Just a couple of things to mention at the very beginning. Why we do that? First of all, because memory analysis is a very deep subject, and there's a lot of things you can become familiar with, because you can spend here 5 minutes, or you can spend 1 hour, or you can spend a couple of days or weeks to analyze different types of memory patterns. And this is a little bit of a challenging subject because it really depends what we are looking for. We can, for example, search within the different memory dumps what happened within our operating system because there was a blue screen. A blue screen is a kernel mode function, key backcheck X, that is actually calling for the blue screen. So when you see that in your dump, it means that blue screen actually happened. So we can see things like this. We can see that there was a driver that caused this. We can see in general the reason. But there are also a couple of other things we can play with over here. If you got some process connecting to the database, whenever you do the dump of this process connecting to the database, question is, will you be able to see the password? Well, that depends how software is written, but possibly, yeah. So you can always check on that. And then within the memory dump, you are able to, even in a clear text, search for the different strings, and then you are able to find out something. Yes, of course, we do memory dumps whenever there is a need to analyze something, troubleshoot something, but for that we're going to spend another part 2, with our useful hacking series, how to troubleshoot. Within this part, we're going to focus on why we should not share dump with the others. Yes, so whenever you perform the memory dump, which I will tell you how to do because this is the intro to the memory analysis, then of course we're going to analyze it in various different ways. I will show you multiple tools that you can use, and then we're going to learn, of course, how to get this information out of a dump and why do we do that. Of course, dumps we can use when the application slows down, when the things are crashing, and so on. So plenty of things you can analyze over there. What's so cool about memory dumps is that there is one saying that I always say, which isn't very discoverous, but still, whatever runs, it's always in the memory. We all know that. But when you're going to start, or maybe when you do this already, to do the memory analysis, you're going to find out what does it mean. Because technically there are so many different things running in the memory that sometimes we are not even aware about. And well, technically, if we are able to grab them, perfect. Mainly depends what we are looking for. Okay, let's have a look. Basically, whenever we think about the memory dumps and the whole purpose, how to do the memory dump, that's the first question we should ask. And there are plenty of ways to do that. Of course, as you see on the slide, we've got a process explorer, process hacker, and so many other process management solutions. But effectively, these tools are the ones that we can play with. We've got also Task Manager. What is quite interesting, because Task Manager isn't very professional tool for performing memory dumps, but why not? These dumps are absolutely fine. So let's have a look. If I do find out, I can sort by name so that the processors are not moving that much. If I could find out a certain process, for example this one, I can always right-click and create a dump file. Yes, so I got a conhost, create a dump file. Yes, I can do that. Okay, I can also go to the local security authority subsystem, which we're going to be talking about, right-click and then create a dump file. Yeah, so that takes maybe a little bit longer, but right now we can see, let me copy that, we are able to see, of course, where this dump is, yes, and how this dump looks like. Yeah? So this is this, as you see, local temp and so on. Yeah? So we can technically get there. We can do that. Okay, and we are in this place, and this is a dump that we have actually created. Yeah, so this is the one. Okay, anyway, let's take this out. So we've got our dump. Anyway, when you perform the dump of the whole operating system, this is also something that it's quite sensitive as the local security authority system. And in order to do that, you need to use, for example, things like dumpit, either memdd, windd, windbg as a debugger. So there's plenty of ways to do it. I'm actually a huge fan of dumpit because it's very easy to use it. Yes, but before we do that, let's have a look at the process hacker. Okay, so I'm going to run it as administrator. Very good. Okay, and we've got a certain, no, let's do close for the moment. We've got a certain processes for now, and we can go, like, for example, to the same conhost and then create a dump file. Yeah, so this is one of the ways. Yeah, so we can do this, create a dump file, and then we can save the dump file like we have it. Okay. Not a good news today. Anyway, let's have a look further. So what about the proc dump? Well, the same story actually. Let's also have a look. I'm gonna just jump to the CMD. We've got also proc dump as one of the tools. It really doesn't matter which version you've got. Of course, it's always good to have the most up-to-date version. I use Debugger at the end, but this is something that I will show you at the end. But procdump is fantastic, and in procdump, the same story. You can do -ma and specify the name of the process. So local security authority subsystem.exe. Yeah, so we got that, for example, and then dump is created. Procdump is free, and you can download it from the www.sysinternals.com. So we should all know that. And procdump particularly has plenty of very nice features. Actually, let's run it and let me show you a couple of them, which within the next seminar we're going to be using for troubleshooting. Yes. So let's see what we've got over here. So for example, one of them it is -p, And let me make it full screen, -p, trigger on the specified performance counter. Exactly. When there is a process that is a representation of a certain application, then we've got a problem, for example, with the memory management. We've got a memory leak or something, and we would like to observe that. How does the memory management look like? Then we can always specify -p, and then we specify the name as we normally have it within the performance counter. Yeah? So this is one of the ways. We've got also -t. Yes, so this is also interesting. When the process terminates, that's the moment when we make a dump. When there is something happening, technically this is the moment that we can provide a dump. So we're going to be, of course, talking about that, but this is a little bit of an intro to make you even more interested to attend the next seminar. But anyway, let's have a look what we can do. One of the things we can do, whenever, and let me go to the memory part. Here we've got, let me just list our tools. There's plenty of things. Okay. We've got our memory. This was the one. MW. Okay, here we go. Let me clear it. We've got here, well, stuff like dump it. Dump it is the process that you can use to perform the memory dump of the whole operating system. That is also very interesting because this is something that allows us to, troubleshoot in general what's happening, or eventually perform the dump after something happened from the security perspective. So, for example, not wishing you this, but server got hacked, yes, and then you need to perform some kind of an operation, like to perform, for example, memory dump. So what tool you're gonna take? What tool you're gonna use? Dump it is definitely one of them. So dump it is actually very easy to be used, because if you do dump it, the only thing it asks you is, are you sure you want to continue? And well, if I say yes, then I'm going to have my whole memory written to the disk, which isn't maybe the best idea right now. But so I will say just no. But if you say yes, then the whole operating system's memory is written to the disk in the form of the mentioned file. Yeah, so this is something that we can have a look at. Okay, so this is a little bit of an intro how we can create dumps. Now, question is how we are able to analyze dumps, because this is also very interesting. And I got here plenty of dumps prepared that we can of course analyze. One of the dumps that we've got in here, it's, for example, it could be this one, hacked PC. Yeah, so we could do that. And if I do choose hacked PC and I analyze it, then I will be able to extract, of course, the dumps like this. I got also plenty of other dumps. For example, the one that is from the Hyperfield. Let me actually get there because it's very interesting. There. And as you see, I got the Hyperfield file that is in a form of a dump file. Now, if I do dir/a, then I'm going to see a little bit more, because Hyperfield says it's a hidden file, it's a system file. That's the first thing. But what I did, I actually used dump it tool to convert the hibernation file. Let me show you into the sys file. I will not do this in front of you because it's going to take a long time, but if you got a hyperfield.sys file, just copy it and then just dump it, and then here you've got a hyber to DMP, for example, or hyber to bin. Yeah, so whatever you're going to analyze, but this is the tool that you can use. Yes, hyber to DMP, and then we're going to get our log. Yeah, so this is the case. Okay, let's move forward. Okay, very good. Let's move forward. So, how do we analyze that? Yeah, so since we already know that we've got here plenty of dumps, well, technically I can take hyperfill7.dmp, let's say, and what happens is that it opens it in the debugger. So this is automatically what I did, and this is what you can. Well, it's a small shortcut that you can add in the registry, just to give a little bit more, intro. There is. Let me actually do this. Here we go. the website Defrag Tools, which is absolutely the best if you want to know more about different Windows internals or in general system internals. But Andrew Richards, Chad Beater, and Larry Larson, and this is actually Angie Richards' OneDrive. They posted the different videos and the OneDrive. So if you click over there, what you're gonna get is something that is absolutely useful, which is this file over here, windbgia.reg. Yeah, that's the one. And when you're gonna get there, what this includes, let's have a look. It's the simple registry entry where, let's have a look. As you see, we are able to, well, first of all, configure the path to the debuggers, but definitely they're going to be in a right-click shortcut. So for the extension is going to be opened by the debugger, and if you right-click on the DBG file, then you're going to actually open it in a debugger. So this is very convenient if you are using a lot of DMP files, which is technically my case. Yes. So that's why when I just open the DMP file, it opens automatically in the debugger. You could be wondering, okay, this is very obvious that when you open DMP, then it opens over there. Well, yes, or not really. Depends what you want to do. But within that reg file, you can also find the debugger extension library, and this is the procdumpxt, and this is the extension for the debugger. So you're gonna also register that extension over there. So it's a very nice registry file. Where you just need to change the path where your debugger is, and then everything's going to be working super duper smoothly. Okay, so I will change the font so that it's convenient for everybody to see and follow what's happening. So let's have it like this. And this is the analysis of the hibernation file. So imagine you share with someone, well, hibernation file, maybe it's not something obvious to share, but some kind of a dump. Local security afterwards, subsystem dump, and so on. So things like that. Or the operating system dump because you want someone to analyze malware and so on. Like, on this computer there's a malware. Could you please tell me how to remove it? This is what's happening. This is what we see on the different forums. There is a fantastic forum called Bleeping Computer where guys actually share memory dumps sometimes, which isn't very cool, as you will see in a moment. And let's have a look what we can get from the hibernation file. So I'm analyzing this one in the WinDBG debugging tools for Windows that you can download for free. But what is kind of inconvenient is that automatically, even though this is a 64-bit operating system, I'm getting into the 32-bit mode. And as you see, Windows 7 kernel version 3x64. So I need to use the command that is called ef. So effective machine, ef machine, yes, AMD 64. We got that. And then we will be able to pretty much list a little bit more. And within this demonstration, I will show you everything in one so that you're going to see how much information, of course, we can get from the dump. So the first command that we use within the debugger, it will be, and it is, it's like hello world in a programming language. It is an exclamation mark process. But unfortunately, well, I can just press enter and then it's going to be a long wait. But just a few words. Exclamation mark process lists us all the details about the different types of processes that we choose. When I do this, I got all of the details from all of the processes, which is absolutely not cool to read. So in order to list something concrete, I need to specify some flags. And the process here, we can, for example, specify the hexadecimal identifier of the process, could be, or decimal identifier of the process. But we can also say that we don't want what is the process ID that we are looking for. I have no idea in this dump. I can always check. But let's say I don't want to. This is the easiest way actually to do it. And then I specify 0 to give me basic information about the process. There are plenty of flags you can use, 1, 2, and so on. And these flags, if you check out on MSDN, provide us more and more or different kind of information that we can use further. But we don't need that, really. The only thing we need is the address of the process in the memory. So let's have a look. What's the address of the local security authority subsystem.exe? We can do that. And then we can take this body, and this is the 64-bit address of the process in the memory. If we have obviously half of it, then it will be a 32-bit. So this is how I can say that this process is probably 64-bit because that address looks like 64-bit operating system address. So this is what we can definitely assume here. But long story short, in order to extract information from the local security authority subsystem, because this is at the end what we need. So regardless if you have a full system dump within this demonstration or hibernation file, or directly made dump as I showed you at the very beginning of the local security authority subsystem, it doesn't matter because it's all the same. At the very end we have to be in this process. Yeah? So .process, I will actually just in case reload my symbols, because I just need to make sure that they are always fresh and so on. And I specify it, not name, sorry, not my fault, just the address. Yes. So .process RP and then the address in the memory. So let's do that. Okay, perfect. And then what we can do is to load the library, load. And now, by default, yes, we are within the debugger path. So we can, of course, specify paths like this if you want, or I can specify something like this. So why do I do this? Because this library, it's within the place where the WinDBG is, in the same folder. It's one of my extension. Well, it's not really that much extension. It's just a simple library, but it's there. So I'm happy to load it without the specification of the path. And I also don't specify the DLL because .load indicates that it's going to be a DLL. And as you see, we have loaded a WinDBG, well, a kind of an extension. It is right now an extension when I loaded that. So I got this one. And we've got, of course, here, this is the Mimikatz, the possibility to analyze the memory dumps within the Mimikatz DLL. We don't load any executable here. It's just everything is in the debugger. It's quite a difficult world, but at the same time very nice because it allows you to perform a lot of things. Anyway, exclamation mark Mimikatz. Okay, and then what we got is a little bit, of course, of the passwords we can get from the memory. For example, the password of the computer account, which is a little bit complex. Is it complex enough? Probably yes. Yeah. So this is one of the things. But of course, as we know from the previous presentations, how Mimikatz works, and I really don't want to be boring, it's just a memory dump analysis. We can get here Freddy Krueger and the password. Yeah. So any dump, like full operating system dump, will contain this. Any hibernation file will contain this. Yes, and the same story, if you perform the single dump of the local security authority system, it will contain this. What is pretty interesting story with you to share is that our developer was analyzing once a funny situation. One of the guys apparently got some malware, and the story was something that this person didn't want to tell the employee that he got a malware, so he went to the forum and he asked people to, hey guys, could you please help me to get rid of it? So yes, of course, please share your memory dump, because the truth is that this is the way to help, but the story, that's the sad part of it, is that you have to share your secret information with someone who's going to analyze your dump. And our developer found out over there, and not only passwords of this guy, because this is very obvious to find that kind of stuff, but also the database, because this guy apparently was some kind of an accountant, and then effectively we knew how much people earn in a certain company. So be careful, because everything, of course, whatever works, it's gonna be in the memory. Okay. So this is how do we connect to the dumps. This is how we perform the dumps, and we already know what is within the dumps from the juicy perspective. Now, question is, how is it possible, and is it possible really, to analyze different types of memory dumps from the different perspectives. Like, for example, I want to get access to all of the DLLs, or I want to get access to this or to that, and so on. So, of course, it is absolutely possible. And in order to analyze memory from that perspective, I would definitely recommend the tool that is called Volatility. And we're going to jump over there. So let's dig in. So our volatility, mine is on the C drive. Our volatility, I have actually put it in the Python 27 scripts folder, which is the default folder for the installation. Now, a little bit of an intro for what do you need to have in order to run volatility. Because if you have a look, volatility, it is actually in Python, yes? So what do we need to do? Well, answer for that is actually very simple. And you need to, at the very beginning, download and install Python for, if you want to run it on Windows, then for Windows. Okay. Now, question is, what kind of? Well, I would recommend 2.7. As you see, I'm using this. 2.7, why? Because 2.7 is compatible with a vast majority of the different solutions that Volatility uses, and different modules in general. Yes? So different functionalities. So if you want to have something special in Volatility and you search for the internet for that, and then you're going to find it, probably it will work with 2.7. It's just generic. Of course, you can try higher, the 3.3, but 2.7 is something that it never really disappointed me from the compatibility perspective. 3.3, yes. So that's why, and I just need to get things working because I need to extract stuff from the memory. So this is why this is happening. Okay, now when you're going to see 64-bit Python, please don't choose it. Take the 32-bit. Why? Because, and again, the same reason, most of the modules that you're going to be playing with, they are actually written for the 32-bit Python. Yeah, so I'm sorry, but you have to do that. So the volatility to Python 2.7 and 32-bit, and of course, on the top of that, you need to get the active Python, and which is also 32-bit, and the volatility is also 32-bit. So basically, just keep that, and for sure everything's going to be working. Also analysis of the 64-bit operating systems, which we're going to do today. So this is a little bit of an intro. Now, why Python? You might be wondering. Well, because a lot of people write a lot of different things in Python that are useful from the memory analysis perspective. If you're going to find volatility in exe file, it's also good, but think about it, because this is a community tool. So when there's something new that pops up, it's up. For example, the new version of Volatility and so on, with new modules and so on. How are you going to adjust it? Yes, because the volatility.exe does not support modules that are custom written. Volatility.py absolutely does. So I would say that this is the main reason. Yeah. So you got a huge variety of solutions in front of you, just waiting to be used. Anyway, let's stop talking and then let's do something with the memory analysis. The first thing we do, it's the volatility.py, and we can specify well, minus f for the file, and in our case we've got dumps in tools and dumps, and we've got, for example, something that is called hacked PC. Why not? And that dump, well, we know, and we can always guess, but in general we know what's the profile. Profile, it is the name of the, well, it is the version of the operating system. Yes, so Win in this case is going to be Win 7, and it's going to be SP1, and it's going to be x64 edition. You can find on the volatility documentation a lot of different types of details about which profiles could you use and so on. And you can also analyze stuff with the Windows 8.2 and so on. So we've got our profile. And first module to be loaded is image info. And don't be discouraged, yes? If something will not work out, which might happen also in our case, why not? Then don't worry, because that's how it is in this sad memory world, that there's a lot of things that you're going to struggle with. If you swear a lot that something is not working, because most of the things are not working, but when you're going to work it out after spending on it a lot of time, then you're going to be very happy. And this first step into memory analysis that I'm talking about right now, it is actually very easy and convenient. So you have no choice but to do it. Yeah? So volatility.py, and then I run the image info module. Right now, what is happening is that the volatility is scanning my image, and it's going to provide me, possibly, hopefully, a little bit more information about what this image is about. Yeah? So this is one of the cases. Of course, the next thing that we're going to do, we're going to play with the different modules like process listing. There's also it's also PS list. This is one of the things. Another one is the PS scan, which is a little bit more detailed analysis. So this is something that we will play with. And well, technically, what I will do, actually, I will. Yes, I don't need an administrative console, but what I will do, actually, I'm going to copy the whole command right now. Why not? And now we get a little bit of info, and we're going to run this simultaneously, yes, so that we are not waiting. Memory analysis requires a little bit of patience. So we've got suggested profiles. Of course, we've got Windows 7, SP1, and so on. We've got, of course, a little bit of information about the operating system itself, what kind of file is this, and so on. So tiny details. Yes, technically, you rarely need that, but I just want to show you the start that we can have. This is like the very first module to be loaded. Anyway, let's move over here. Python scripts, and we're going to analyze the same thing here, but instead of image info, so this is my second console here, instead of image info, I'm going to do PS list to list all of the processes over here. This is actually quite quick. Yeah, so at the beginning you see that we've got the different process names over here, yes, and that we've got also process identifiers. Yeah, so we are able to spot that. What is pretty interesting is that you've got also parent process ID. So this is very important to know who started who, especially when we are dealing with the malware analysis. But we can also get information about well, different processes loaded during the dump situation. What is pretty interesting is that within that scenario, not actually all of the processes are loaded. Yes, let me show you this. I'm going to enlarge this. Not all of the processes are loaded. So we got here a pretty nice list of the processes, but there is no process with a name malware.exe. Yes, it's only mimikas.exe, but not malware.exe. How to find it? Well, absolutely. There is an option PS scan, yes, which runs a little bit longer, but as you see, not too bad. And over here, we are able to find eventually the processes that are hidden. Yes, so we are able to spot that. Yes, so there could be a little bit more. The same story is within the different dump. Yes, so let me actually choose the different dump. It's going to be a little bit more interesting, I think. In this case, we got our analyze PC profile, and the profile is actually the same. We've got a SP1 x64 and PS list. Let's have a look at the difference. We got it. And then, of course, we've got a series of processes over here. And then if we do PS scan, yes, then we're going to be able to see a little bit more. Yes, and this is particularly the dump where we've got our malware.exe. So as you see, this is actually pretty simple. You're probably wondering why on one list, when we do PS scan, this exists, and when we do PS list, it doesn't. Well, answer to that question is actually very simple. What is happening is that in operating system, we've got something that is called active process links, which is the mechanism that is used in the operating system to list processes, like literally list processes. So when you got a task manager, thanks to active process links, the processes are listed. So technically, when you cheat on this list, which we're going to be talking about later on within the next series because it's a very interesting subject, when you cheat on this list, you can actually hide processes. This technique, it's called DKOM, Direct Kernel Object Modification, and this is a technique that is actually used by rootkits. So you might be interested in that. Anyway, so we know, of course, how to spot the processes that are eventually hidden or not showing within the first search, but there are also a couple of other searches we can get. For example, DLL list, and we can get the list of the different types of DLLs loaded within the processes in order to identify. If you have a look, it's actually a very big result. In order to identify where, of course, by the DLL maybe, that process is has certain types of information. Yeah. So if I know that this DLL is not cool, question is which process loaded that. Yeah. So this is one of the options. Technically, there is also an option when we're going to do DLL lists. I can always DLL list. I can always extract it to the file. There is also an option to get the files. But these files, unfortunately, they're not that clear to be read. Yeah? So I will show you right now how to extract the files. File dump. And I can specify -n minus process ID from the DLL list. Let's have a look. So here, DLL list.txt. And for example, I'm searching for event log. Yeah, so I want to get the event log. So WEVT. Yeah, so this is the one. Actually, this is the one, the service. And who hosts this within this dump? So I can check. And this is actually the SVC host. Yes, with the process ID 956. So I can take that. Let's do it within the other console. And I'm able to extract the information, yes, from the dump. So this is the particularly, this was the hacked PC. So we can do this over here. SP, OK, process, and then folder bank. OK, so then we get it. Of course, we've got, right now we are dumping the files. And we are able to spot that we've got, for example, EVT access. Well, all the other files that are within the handles to the certain process, are they complete? Are we able to read them? Well, not in this case actually, but sometimes when you got some text files and so on, then you will be able to read them absolutely. Yeah? So these are the files that you are able to get. Yes, and I'm extracting them into the parent folder. So this is scripts, and then I get a folder file handles, and they all gonna be there. Yeah, so this is one of the options. Okay, guys. After that, question is what else we can do. Yes, I can interrupt it. What else we can do? Well, we can, for example, scan for the different types of different types of things that were opened within the within the certain process. There is a module that we can use. It's called consoles. And the module consoles allows us to see what kind of commands were run in the cmd.exe. So this is actually pretty cool, because if something was happening, then you are always able to find out what kind of stuff was run, yes, within the command prompt. And at the same time, what I'm going to do, I'm going to take this command, I'm going to run it simultaneously because it's going to take a little while. That's why I'm doing this, which is called cmd scan. Scan. Here we go. Also very nice. And when we have a look at this, so we've got these two, yes, and one already worked, which is great. Yes, so we've got consoles. And then, as you see within consoles, what we can see is what was typed. Yes, so we've got a privilege debug, for example. Yes, so this is the con host, and what was run inside. Yes, so we can see, for example, what kind of commands were there: cd, cd tools, psexec, stuff like that. Yes, so mimicat. So someone was doing something. Yes, and as you see, someone is browsing the folder to tools, psexec, and so on. So we can see what was actually executed over there. Yes, and of course, like whatever someone saw. Yeah, so we can also spot that kind of information, what was within the console. This is a little bit shorter. CMD scan, we also able to see what someone saw, what someone did, but in a short form. Yeah, so this is something to show you. Yeah, so there are two options. What else that is interesting? Actually, there are even more. So you can have a look at the different modules. I'm going to interrupt this one. CLS, and what you can also spot is or are things like network analysis. This one is actually quite long, so I'm just going to run it. Net scan, and you can of course dump the different types of network connections that were made during the when we were performing a dump. Yeah, so this is also quite important. So you can check out, was this workstation connected to the network? Is there someone that was browsing some weird website? Were there some weird connections made? So this is something that you can also have a look at. Okay, so from the like simple intro perspective, well, there's also another quite useful module. So it is the service scan, so we can actually run it within the next console within this one. So I can just interrupt it. Okay, good. So there's plenty of things that were happening. As you see, someone saw deer or someone did deer. Yeah, so why not? We can also get the service scanning. Yeah, so another module, SVC scan. Yeah, so we got that. And then we're going to get information about the different types of services and the statuses of the services within the operating system. Yeah, so I'm going to stop it for the moment, but as you see, we've got different types of services that we're running at that moment with the different parameters, also very cool. And you can verify if there is something that is weird, suspicious, or not. Yeah, so this is one of the ways. Yeah, so I'm stopping partially things so that you can see actually what kind of stuff we are listing here.